All right, here we go. So we're going to talk about what a residual plot is. So a residual plot is literally a plot of every residual value. So what should happen if we've chosen an appropriate line of fit is that our residuals would be plotted with, you can either use your x-axis, your original, or your y-axis. It doesn't matter. I'm going to sketch in what that would look like. So this is going to be my height. It could be shoe size though, okay, but I'm going to use height. And then my residual values, some of them will be above the line of fit. I'll just call that 1 unit. And some of them will be below the line of fit, and this would be a 0 residual. And so this axis here is our residual values. That doesn't mean that they'll only be from 0 to 1, by the way. This could be over 1 and under 1 and under -1. So what I would do, I'm just going to give you an example. This person who was 70 inches, so we'll go 67, 68, 69, 70, 71, 72, 73, 74, 75, 76. So this person who was 70 inches, so 67, 68, 69, 70, 71, 72, 73, 5. Right here, right? He had a residual of 1.3, yeah, almost 1.4. And so his residual value would be like right here. And this person who had a height of 73 inches, so right here, he had a residual of -1.24. So like roughly right there. And what will happen is some of our points will be above and about the same number of points will be below. So for example, this person is about, looks like about a half, right? So maybe right here. This person is also above by maybe 1.5-ish. I'm just estimating here. Actually, no, by less than that. It's about by 0.75. And so on and so forth. And so you'll have a few people above the line of fit and a few people below the line of fit. And they'll line up, that you'll have another one below the line of fit about right here. And so on and so forth. There'll be one above, another one that's just slightly above, and one that's maybe right on, and maybe another one over here that was right on. It looks like it's 70 inches. And so your residual plot should be really super boring. So all I've done is I've pretty much like eyeballed the distances from here to here and the distances from here to here and so on and so forth. Now to see your residuals, you can make your calculator calculate your residuals for you. And it's really kind of cool. You don't even need to do anything. Your calculator knows how to find residual values. So if you go to second list, you should see something called resid. And those are your residual values. Now, if yours are not there, you need to get into a Zoom meeting with me and I'll show you how to put them back. But I'm going to take that residual and I'm going to store it into list 3. Or you don't even have to do that. You can, if you go to your plots and you go up here to where it's all the way over where there's nothing, right? So I'm going to clear this out. See, I have CNTRB, that's contribution, that's for a chi-squared. You're going to go one more to where it's blank, and you can literally insert your residual list there as well. So you go to second list and hit residual, and it will store them right there for you. But I prefer to put them into list 3 so that they're right next to my values. And then by looking at my residual list, now I can see every single residual and make sure that I indeed had the highest residual value. So remember my largest residual value was 1 point, I found a larger one, actually. 1.3968. Oh, I think that is the guy. No, that is him. It's just a little bit off because we're rounding our numbers. So he was the largest residual. Same person, right? He happened twice. So there were actually two that were the same height and the same shoe size. Okay. All right, so back to this. We're going to look at our residual plot. So to do that, we go to second stat plot. Make sure that your plots are on. And then remember when I just sketched my graph, how I said I wanted my X values to be the list 1, right? But I want my Y value now to be residuals. So I go second, list, and I'm going to insert the word residual. And then hit enter. So when you're on your Y list, go to second, list, and then insert the word residual. All right, I'm going to zoom 9 this guy and look at my residual plot. And what's funny is it looks very similar to what I sketched. Similar, not exactly the same. I was just estimating. But there's my residual plot. Now, a residual plot should look like that, boring. There's no real shape to it. It's not a linear shape. You don't want any kind of linear or funneling or anything like that. It's a tiny bit funneled, just a bit. It kind of funnels down, but not bad at all. So it is a good residual plot. Because, oops, I'm on the wrong one. It is a good residual plot because there is no apparent shape or funneling. Okay, now we're going to do the same thing again. We're going to do a plot of shoe sizes instead of the heights. So all we're going to do is we're going to go to second stat plot, and we're going to change, instead of using the height, we're going to put the shoe sizes there, which was list 2. So second L2. And then I'm going to zoom 9. And what I notice is it looks really similar to the other one, except for it's going the other direction. And so it is also a good residual plot because there's no apparent shape or funnel. So both plots are good plots, and you can use either one. You can use your height or your shoe size. All right, we're going to calculate the standard error by hand and then interpret it in context. So S sub E is equal to the sum of all of our errors. So that's actually kind of cool because we don't have to do these by hand. We have a list now of each of those values. They're in list 3. And if I wanted to sum them, I could actually just do a stat calc one variable stats on list 3. And what you notice is that when it'll sum them up for you. The sum of list 3, so the sum of our errors is 0.12345 6, 7, 8, 9, 10. And this is 1.2, so negative over n minus 2, which is 12 minus 2. I don't think I should have a negative here, so I think something happened. Let me see. Oh, yeah. My squared is missing. how did I miss my square right here? If you go back and you look at the equation, it should be squared. You can't square root a negative, so there should be a square right here, guys. So let's go ahead and fix that. All right. Okay, so again, my sum was negative 1.2 to e to the negative 11. So I wrote that out. That would be 10 zeros in front. And then I'm going to square that. So second quit, 0.12 squared. So that's 1.44 times e to the negative 22. And I'm going to divide that, divided by n minus 2, which is 10. And then I'm going to square root my answer. And so the standard error is 3.795 times 10 to the negative 12, or 0.123, 4, 5, 6, 7, 8, 9, 10, 11, 3795. So it's a very small standard error, and it should be. Okay, find and interpret R squared. So you can use your R value. Remember from the previous page, which is where, I don't know, I'm looking for it. Hold on, here it is. R was 0.73262. And so R equals 0.73262. Well, then R squared. So something that we know about R, just to remind you, is that R is always between -1 and +1. So if I square this value, I am always going to get a number that's between 0 and 1 inclusive. All right, so I'm going to square 0.73262. 0.73262 squared is 0.5367. And then it says interpret R. Oh, and I didn't interpret here, but I did in words, but interpret this in context. The standard deviation of the residuals is very small, which tells me that this is a good line of fit, right? That this is the least squares line. Okay, find and interpret R squared. So this one I've heard them ask for the interpretation of R squared. So this is a fraction or percent of the variability in Y that can be attributed to the model or the variability in X. So the way I would say it is 53.67% of the variability in Y, which was shoe sizes, can be attributed, let me see if I'm probably off the screen, yes, can be attributed to the variability in height. Or at this point you could say can be attributed to the model for height. But I prefer this one right here and not so much this one, based off of the way that they've scored in the past. And then it says, have we met the assumptions and conditions for linear regression? So now we're actually going to add one assumption / condition. So recall from last week, there were 3. So first we had to have quantitative data, which we already verified last week. check, and check. You have to check both. The second one is that you have to have straight enough data. And I'm going to say check to that one as well. The scatter plot is fairly linear. And then the third one was the outlier condition. And I'm going to say check to that as well. It did not appear that there were any severe outliers. But the fourth one now is called, does the plot thicken? And they're talking about the residual plot. So our residual plot should be boring without any real direction. So this one, it's a little iffy. It's still pretty boring, but there's a little bit of a linearity to it, but it's not super bad. And the same thing with our other residual plot the one I sketched. I don't want to redo it, but it's fairly good. There is a little bit of what's called funneling. So it almost looks like a bit of a funnel, almost. If it wasn't for this like one point right here, it would look like a more of a funnel, but it's an okay residual plot. So we checked the residual plot and it looks all right. Let me see if there's anything else. No, that's the end. Yay. All right, so please understand that these interpretations, they're very important. I'm giving you your script. Like, remember how I said we always say this in our conclusion. We are 95% confident that the true blah, blah, blah of this lies in the interval, blah, blah, blah. Okay, these interpretations are just like that. They're very, very important. So when we interpret the slope, you must say for every blank increase in x, y is predicted to either increase or decrease by blank units. You have to every single time. The y-intercept, when you interpret it, the y-intercept of blank indicates that if, and then in context, right, had a x of 0 units, their predicted y would be, and then tell them if it makes sense or not. Predicting the shoe size, extrapolating beyond data, right? Applying the model to someone who does not fit the model. How good is a model at predicting these? That it's a good model if the people are close or have small residuals. This person had a larger residual, so did this person. Describe what you see. Your residual plots should be boring with no shape or funneling. Please make sure you fix this. This should be a squared. Interpret in context. I know I didn't write it down, but our standard deviation of the residuals, I'll do it now. The standard deviation of residuals is extremely small. Close to 0. And I should have put right here of the residual values for height versus shoe size. Okay, so let's add that for height versus shoe size. Find and interpret r squared. This is where we use a percentage, never on r, only on r squared. 53.67% of the variability in shoe size can be attributed to the variability in height. So that means that the rest of the variability, remember we have 100% variability, right? About 54% of it is coming from the height. And then the rest, the remaining 46%, is coming from other factors like genetics or maybe nutrition or something like that. And then have you met the assumptions and conditions for linear regression? Remember there are now 4. Quantitative data, straight enough, outlier condition, and then the residual plot. You have to check all 4. All right, guys, that was the notes for chapter 8. Have a good weekend. Well, it's the weekend for me. It's Friday. So All right, bye-bye.